Hi everyone. In this video, I'll be reviewing Chapter 1, Sections 1.2, 1.3, and 1.4. So let's start with Section 1.2, which is on variables and types of data. So let's look at a little flow chart here. So we've got variables, which can be broken up into, firstly, two parts, namely qualitative or quantitative. And qualitative, those are pretty arbitrary. They talk about some quality of the object. So they can't be directly measured by a number. That would be things like, color, maybe the type, things like that. And quantitative, that's things that can be counted. And then quantitative variables can be further broken up into two portions, either discrete or continuous. So discrete variables, that means, well, first let me write, a little note about qualitative. You want to think about some sort of quality that the variable has. Maybe it's a color or a type of some sort. I'll probably think of another one in a minute. And then discrete variables are a quantitative variable, and that's when we've got a whole number of things. They can be counted. This would be things like the number of ducks on a pond, for example, or how about the number of cars in a lot? Right, you can't have a fractional amount of ducks on a pond. You can't have a fractional number of cars in a parking lot, right? If somebody asks you how many ducks are in that pond, it's going to be 3 ducks, 4 ducks, 5 ducks. It's not going to be 3.5 ducks. It's not going to be 3.25 ducks. Nothing like that. That's what it means for it to be discrete. Whereas a continuous variable means it can take any range between a certain number of values. So, for example, weight, you can keep chopping it up into smaller and smaller pieces, right? So weight, you could be 185 pounds. You could be 185.5 pounds. You could be 185.5237 pounds. If you want to get the exact measurement of their weight, you could, it could be, any decimal there, right? Things like, what else? Height, right? You could be 5'9". You could be 5'9" and a half. You could be, 5 feet 9 inches, 5 feet and 9.5 inches, 5 feet 9.25 inches, 5 feet 9 1/8 inches, right? You can keep chopping it up into smaller and smaller. You can keep getting more and more of an accurate number. So this is for continuous. You want to think of it can take any value between, or I should say, in a range of values. So that would be things like, weight, height. Let me try to think of one more. How about age? Right? So I'm 35 years old, but technically I'm really, my birthday is in December. So I'm really 35.862 something years old, technically, right? So again, that would be a continuous measure. So let me pull up an example here just to get a little bit of practice. Okay, so I've got an example here from the book. It's asking us to classify each of these variables as being discrete or continuous. So, for example, in A, it says the number of hours during a week that children ages 12 to 15 reported that they watch television. So, I would imagine that that would be, well, go ahead and pause the video, try for yourself, think about it yourself. That is continuous, right? Because it's a measurement of time. So similar to age, maybe they watch 3 hours, 3.5 hours, 3.25 hours, 3.125 hours, 3.16 hours, right? It could be, you could keep breaking it up into smaller and smaller intervals or smaller and smaller fraction. So this one is definitely continuous. And in general, time is basically always going to be a continuous measurement. Sorry. B, the number of touchdowns a quarterback scored each year in his college football career. And so think to yourself, can you have a fractional number of... Oh, I think I maybe being a little bit too loud here. I should probably turn the mic down a little. I think that's better. Okay, so sorry if I was being a little bit too loud there for a bit. Hope that's better. So the number of touchdowns a quarterback scored each year in his college football career. So, right, you can't have a fractional number of touchdowns. So this one's going to be a discrete measurement, right? You could have 3, you can have 4, you can't have 3.5. You can't have anything in between that range, right? So it's only a counted number. C, the amount of money a person earns per week working at a fast food restaurant. This one can be a little tricky. Go ahead and think about it yourself. Well, the answer is there actually is a smallest unit for money, right? That's a penny. You can't get smaller than a penny. So you could either have, 5 cents or 6 cents. You can't have 5.5 cents. That doesn't make sense. So there is a smallest unit. And so that means technically they can be counted in that number of units, cents, pennies, right? The number of pennies in the dollar. And so this is a discrete measurement. And for D, the weights of the football players on the teams that play in the NFL this year. Well, weight, again, that is something of that can take a range between any two values. Or between two specific values. So between 150 and 151, right? You could get to 150.5, 150.25. You could keep breaking it up in that range. And so this one is a continuous variable. We also can classify measurement scales into a couple different types. We've got nominal, ordinal, interval, and ratio. And first of all, nominal level measurement classifies data into mutually exclusive, non overlapping categories in which no order or ranking can be imposed on the data. We've got ordinal means that it classifies data into categories that can be ranked. However, precise differences between the ranks do not exist. Interval level ranks data, and precise differences between units of measurement do exist. However, there is no meaningful zero. And ratio possesses all characteristics of interval measurement, but there exists a true zero. In addition, true ratios exist when the same variable is measured on two different members of the population. And so the typical things that might be mentioned in this class, we've got a couple examples here. So nominal, remember, they could be put in groups. They're non-overlapping, and no order or ranking can be imposed on the data. So for like zip codes, right? Zip codes, they don't overlap, and there's no ranking between them. Like you can't say one zip code is better than the other or ranked higher than the other by zip code. It just doesn't make sense. They might be ranked. You might be ranking them in terms of other things, but anyway, like eye color, blue, brown, green, hazel, like. Do you say one is better than the other? Like that doesn't really make sense. How is one eye color better than another? Nationality, etc., etc. Ordinal. Remember, this puts them into groups which can be ranked, but there's no precise differences between the ranks. So, for example, a grade A, B, C, D, F. Although I guess technically the grade, an A is between 99 and 90 or whatever. So it's not like an exact measurement. I guess the exact grade would be not ordinal; it would be different. But the letter grade would be ordinal level. Judging, like first place, second place, third place, like first place is judged to be better than second place, but by how much? It's not like a very specific amount. A rating scale, poor, excellent, good. Again, there's no like how much better is excellent than good, how much better is good than poor. It's not like a rigid amount difference. Rankings of tennis players, the number one ranked tennis player is better than the number two ranked player, technically, but by how much? It doesn't really say how much better, just that they are better. Whereas interval level does rank the data, but there is a precise difference about how much better one instance is than another. So, like, when you're comparing 80 degrees to 40 degrees, 40 degrees is exactly twice as hot, or I'm sorry, 80 degrees is exactly twice as hot as 40 degrees. There's like a very decidable difference. Same thing with SAT score, IQ scores, things like that. And ratio level, there exists a true zero, so that's things like height, right? You can't be a negative height level, whereas you can have a negative temperature, right? I guess IQ scores and SAT scores, like, I'll talk about the ambiguity in a second, but I feel like that could probably also go to ratio. But there is some ambiguity between interval and ratio. I'll talk about that in a second. It's not too super important. So if you get a question like that wrong and you have to redo it or whatever, it's not the end of the world. And like someone who's 20 is twice as old as somebody who's 10, right? Whereas I guess, yeah. Anyway, let me talk about the ambiguity because some of that doesn't make sense. So it says there's not complete agreement among statisticians about the classification of data into one of the four categories. For example, some researchers classify IQ data as ratio data rather than interval. Also, data can be altered so that they fit into different categories. For example, if the incomes of all professors of a college are classified into the three categories of low, average, and high, then instead of it being ratio level, it becomes an ordinal level. But here are the common examples that we'll try to agree upon for this class. Again, there's some ambiguity between interval and ratio. If that happens, don't worry about it. It's not too big of a distinction. It's not too important of a distinction, I should rather say. And that should include section 1.2. Let's go to section 1.3, which is on data collection and sampling techniques. Okay, so I think there's 4, right? Yeah, there's 4 main ones that are discussed in the book. Number 1, we've got random sampling. And random sampling is when all members of a population have an equal chance of being selected. So say it's a lottery, right? Everybody's assigned a number, or a raffle. Say it's a raffle and everybody gets 1 ticket, only 1 ticket. And then they pick a ticket from the bowl. Everybody has an equal chance, and it's completely random of who is selected, right? Maybe they pick 5 from the bowl. That would be a random sampling, because they all have an equal chance of being selected. Next, we've got systematic sampling. And systematic sampling is more used for, like, quality control, basically. It would be used, say, at a milk manufacturing company or milk pasteurization company, whatever. They test maybe every 20 off the conveyor belt, just to get a good spread while not having to select every single one, right? That would be an example of systematic sampling. It's like every blank, they make a K, right? Every K items, the kth one will be the next one put in the sample. So if K is 10, it would be the 10th one, then the 20th one, then the 30th one, then the 40th one. All would be included in the sample, whereas all the rest wouldn't. We've got stratified sampling. And stratified sampling sorry, my mic got disconnected there. Don't know why. Stratified, for example, suppose the president of a 2-year college wants to learn how students feel about a certain issue. Furthermore, the president wishes to see if the opinions of first-year students differ from those of second-year students. The president will randomly select students from each subgroup to use in the sample. So, he wants to see how the opinions of, say, freshmen, sophomores, juniors, and seniors differs. And that's relevant to the study because, he's seeing how they differ between that strata of that group, right? Those already existing groups, essentially. They divide them into some characteristics. So maybe that's essentially them dividing the population, right, the whole student population, into strata based on their grade level. Maybe we could also base it on strata of their gender. Then it would be males versus females. or strata of uh, I don't know, STEM majors versus non-STEM majors or something like that. And then we've also got cluster. And for cluster sampling, I always want you to think about location. That's a good way to tell about the difference between stratified and cluster because they kind of are a little close together. For cluster sampling, it's obtained by dividing the population into sections or clusters and then selecting one or more clusters at random, using all members in the clusters as members of the sample. Um, so it says here the population is divided into groups or clusters by some means such as geographic area, um, or something like that. And the main difference between stratified and cluster is that although both types of sampling, the population is divided into groups, the subjects in the groups for the stratified sampling are more or less homogeneous, that is, they have similar characteristics, while the subjects in the clusters form miniature populations, right? So they have nothing different other than where they are, essentially. Okay, and so I've got another little helpful chart here from the book. Random subjects are selected by random numbers. Systematic subjects are selected by using every kth number after the first subject is randomly selected from 1 through k. Stratified subjects are selected by dividing up the population into subgroups or strata, and subjects are randomly selected within those subgroups. Usually it's the same number in each of the subgroups. So while there might be more freshmen than sophomores, they would select 10 sophomores and 10 seniors. It would always be the same number usually. Or always, I should say. And then cluster subjects are selected by using an intact subgroup that is representative of the population. Essentially, for that one, think of where they are located. It's always a locational thing. Okay, and so I've got another example here from the book. And it's asking us to classify these, according to which sampling method is used. So in A, it says, out of 10 hospitals in a municipality, a researcher selects one and collects records for a 24-hour period on the types of emergencies that were treated there. Okay, so they've got 10 hospitals, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the researcher selects one at random, I guess. So let's say they pick this one. And they're going to collect records for a 24-hour period of the types of emergencies that were treated there. Okay, so what do you think? Okay, well, this one is cluster. And again, it's because that population is only selected on where they are located. Right? It's an intact group, all the people in this hospital. And then we pick that group, and that group should be representative of the entire population. They could pick one group. They could pick. She selected one here, but it could have been more than one. But this one is cluster because it's based on their location. That's what's different about them, where they are. So B, a researcher divides a group of students according to gender, major, field, and low, average, and high grade point average. This one's a little, I think, bad question actually, because these are overlapping actually. Then she randomly selects 6 students from each group to answer questions in a survey. But yeah, this one, I think it's a bad question. I've seen this one before. And stratified, they're supposed to be non-overlapping, whereas some of these would be overlapping, right? Gender and major field, obviously, there's going to be overlapping. So, but this one is stratified. A bit of a boo-boo there by the book. C. The subscribers to a magazine are numbered. Then a sample of these people is selected using random numbers. That one is a random sampling. It's very similar to the raffle example that I mentioned. And D, every 10th bottle of energized soda is selected. That's the K I selected earlier, interestingly enough. And the amount of liquid in the bottle is measured. The purpose is to see if the machines that fill the bottles are working properly, right? They'll maybe measure the height of them to see if they're all getting close to the agreeable range of what's good. But anyway, yeah, this one is systematic because it's every 10th one. Okay, and that covers section 1.3. And what about 1.4? This one's on experimental design. Check something real quick. Okay, so in this section, they first classify a study into two different approaches. Either one, an observational study, or two, an experimental study. And in an observational study, the researcher is only observing what is happening or what has happened in the past and tries to draw conclusions based on these observations. So they're not actively doing anything to the subjects being researched. They're not making any changes, essentially. In an experimental study, the researcher manipulates one of the variables and tries to determine how the manipulation influences other variables. So, maybe maybe it's like, they're trying to test this new drug, whether it works or not. They're doing essentially an experiment on their subjects. They're not just observing what happens; they're controlling what happens, and that's pretty much the difference there. And in an experimental study, the independent variable is the thing being manipulated. The independent variable is also called the explanatory variable. And the resultant variable is the dependent variable or the outcome variable. There's also something called a confounding variable, which is one that influences the dependent or outcome variable but was not separated from the independent variable. So confounding variables are things that cannot be accounted for, essentially. They've got here in the book, for example, subjects who are put on an exercise program might also improve their diet unbeknownst to the researcher, and perhaps improve their health in other ways not due to exercise alone, right? The researcher might be testing, how much exercise a person gets in a day influences certain things. And they're measuring how much exercise they get a day, as well as other things, and trying to see some correlation or something like that. But they don't know everything that's happening. They're only getting certain measurements. They don't know everything that happens in the people's lives. They don't know what they're eating, how much sleep they're getting, if they're lying. Things like that might be what are called confounding variables, things that the researcher cannot account for. Okay, so I've got another example here from the book. Let's go ahead and read it. Researchers randomly assigned 10 people to each of 3 different groups. Group 1 was instructed to write an essay about the hassles in their lives. Group 2 is instructed to write an essay about circumstances that made them feel thankful. Group 3 was asked to write an essay about events that they felt neutral about. After the exercise, they were given a questionnaire on their outlook on life. The researchers found that those who wrote about circumstances that made them feel thankful had a more optimistic outlook on life. The conclusion is that focusing on the positive makes you more optimistic about life in general. Based on this study, answer the following questions. Just go ahead and try them on your own. A, was this an observational or experimental study? What is the independent variable? What is the dependent variable? What may be a confounding variable in the study? What can you say about the sample size? Do you agree with the conclusion? Explain your answer. Go ahead and try to think about these on your own. Okay, let's go ahead and try them together. So, is this an observational or an experimental study? This is definitely an experimental study. They're very actively telling these people what to do. B, what is the independent variable? So what is different between each group? That's what the independent variable is. And in this case, it's what they're writing about. The type of essay that they're writing, essentially, right? What is the dependent variable? So remember, the dependent variable is what they're trying to see is affected. And here it says, after the exercise, they were given a questionnaire on their outlook on life. The researchers found that those who wrote about circumstances that made them feel thankful had a more optimistic outlook. So what were they measuring here? After they wrote an essay, they're measuring their outlook on life and seeing if the essay that they wrote affected that. So the thing being affected, that's the dependent variable. In this case, it's their outlook on life. What may be a confounding variable in the study? Well, there's a lot. A whole lot. But let's name a couple. How about maybe they were just in a bad mood that day, and so it didn't matter what they wrote about. They were going to have a bad outlook no matter what. Maybe they're in a good mood that day, and no matter what they were asked to write about, they were going to have a good outlook on life. So just their general mood. And mood can be affected by a lot of things. Maybe what they ate, how much sleep they got. If they got in a fight in the morning, there could be a lot for this. Very, very many answers. What can you say about the sample size? The sample size, that's the total number of participants. Well, here it says he randomly assigned 10 people to each of 3 different groups. That's a little, I hate the wording there, but this is 30. There's 10 in each group, so there's 30 participants. And then F, do you agree with the conclusion? Well, I guess answers vary here. There's no right answer to this, but I would say yes. I would say yes personally. I think when you are positive, or I guess when you're thankful, you are more positive in general. I guess. So I hope that makes sense. And I hope that's a good review for the chapter. I believe you just have to say, like, yes, I watched the video at the bottom in order to get credit for this. So thanks for watching, and I'll see you guys in the next video.